On September 7, 2025, WestJet flight WS-2652 approached Princess Juliana International Airport in St. Maarten. The Boeing 737-800, with 157 passengers, was on a routine flight from Toronto. The iconic approach over Maho Beach was a spectacle for tourists and passengers alike. The weather was clear, and the pilots, seasoned professionals, were executing a standard landing. The aircraft was properly configured, with all systems nominal. But hidden within the aircraft, a critical metal component was on the verge of catastrophic failure. The aft trunnion pin, connecting the right main landing gear to the wing, had developed a microscopic crack. As the plane flared for landing, this flaw was about to turn a routine landing into a major incident. The chain of safety, forged through engineering and maintenance, was about to break. This incident would send shockwaves through the aviation industry. The touchdown was routine until a loud bang echoed from the right side. The right main landing gear collapsed, causing the aircraft to lurch sharply. The plane slammed onto the runway, with its right wingtip scraping the ground. Sparks flew as the engine cowling was torn apart. Inside, passengers were jolted as the plane veered uncontrollably. The flight crew fought to maintain control, using rudder and brakes to keep the jet on the runway. The aircraft skidded to a halt, resting awkwardly on its left gear and damaged engine. Emergency services responded instantly, dousing the area with foam. The crew directed passengers to evacuate via slides on the left side. All passengers and crew were evacuated safely, with only one minor injury. The incident shut down the airport, prompting an investigation. The question remained, what had gone so terribly wrong? The investigation into the WestJet incident began immediately. The Transportation Safety Board led the inquiry, focusing first on pilot error. A hard landing was ruled out after analyzing the flight data recorder. The data showed a normal landing profile with forces within acceptable limits. With pilot error off the table, attention turned to the hardware. The right main landing gear had collapsed due to a failure at a key attachment point. The preliminary report confirmed a mechanical failure, not operational factors. The aft trunnion pin had fractured, leading to the gear collapse. The investigation shifted to a metallurgical analysis of the broken pin. The pin was sent to Ottawa for in-depth analysis to uncover the root cause. Investigators aimed to determine if the failure was isolated or systemic. The findings would have significant implications for aviation safety. The trunnion pin is crucial in the landing gear assembly of a Boeing 737. It connects the gear to the wing spar, bearing immense loads during landing. The failed aft trunnion pin was susceptible to metal fatigue. Fatigue occurs when cyclic loading causes microscopic cracks to form and grow. The metallurgical analysis would examine the fracture surface for signs of fatigue. Investigators would also consider manufacturing defects or corrosion as potential causes. The investigation would scrutinize the pin's manufacturing records and maintenance history. The goal was to determine if the failure was an isolated event or indicative of a wider issue. Trunnion pin failures on Boeing 737s have historical precedents. Past incidents, like a 2005 Southwest Airlines case, highlighted vulnerabilities. Fatigue cracks in trunnion pins are difficult to detect without advanced inspections. The WestJet aircraft's maintenance history became a key focus. The plane, over 16 years old, had its last major overhaul in 2016. Investigators questioned if current maintenance intervals were adequate for aging fleets. The TSB's review aimed to identify trends and assess inspection methods. A pattern could lead to significant safety recommendations for the Boeing fleet. The incident at Princess Juliana Airport added complexity to the failure. The airport's short runway and challenging approach required precise piloting. The crew's skill prevented a runway excursion, maintaining control despite the failure. Their actions ensured the safety of all 163 people on board. The cabin crew's calm response facilitated a swift evacuation. The incident tested both machinery and human performance. While the trunnion pin failed, the crew's professionalism prevented catastrophe. The event highlighted the importance of training and skill in aviation safety. The crew's exemplary handling of the emergency was a critical factor. The incident underscored the resilience of the aviation system. The WestJet incident occurred amid post-pandemic pressures on aviation. Airlines were scaling up operations, straining the aviation ecosystem. maintenance facilities faced technician shortages and supply chain disruptions. The accelerated tempo raised concerns about aging components. The Trunnion pin failure highlighted issues with aging aircraft. Metal fatigue is a cumulative process, increasing failure risk over time. The incident raised questions about inspection intervals and component life limits. The TSB's findings could lead to industry-wide changes. The investigation's outcome would be closely watched by the aviation industry. A systemic issue could trigger significant regulatory actions. The WestJet incident serves as a case study in aviation safety. The crew's handling, emergency response, and aircraft design ensured a safe outcome. The failure of a single component highlighted the importance of maintenance. The investigation focused on the Trunnion pin's integrity. The aviation industry awaited the TSB's final verdict. The outcome could influence maintenance practices for the Boeing fleet. Every incident is a lesson, strengthening the safety chain. The incident reminded us of the trust placed in technology and people. The successful outcome showed the system's resilience. Diligent investigation and implementation of lessons ensure safe skies.